All right, and welcome back. So today we are going to be continuing solving these quadratic equations, but this time we're going to be talking about how to solve it by factoring. This is going to correspond to section 8.6 in your guide and notes, so please have them out. Let's begin. So quadratic equations can be solved by factoring and using what's called the zero product property. If the product of two quantities is equal to zero, at least one of the quantities must be equal to zero. And this should make a little bit of sense as we start to talk about some numbers. If we have 2 times 0, well, that's 0. If we have 0 times 2, that's also equal to 0. So we're going to be using this idea of having two numbers or two quantities multiplying together to give us 0 to help us solve. So if x times y is equal to 0, then again, either x is equal to 0 or y is equal to 0, because one of them has to be 0, because 0 times anything is 0. So using that, if we replace the quantities x and y with x plus 3 and x minus 2, then x plus 3 has to be 0 or x minus 2 has to be 0. One of those binomials has to have a value of 0. That way, when we multiply its value with the other value of the binomial, we end up getting 0. So we're going to use this zero product property to solve x plus 8 times x minus 5 is equal to 0. And then we're going to check our answer. So we have the binomial x plus 8 times the binomial x minus 5, and that's equal to 0. So we're going to identify the possible x values that when we substitute into each individual binomial, one of them has a value of 0. So to do that, we're going to break it apart. We're going to end up with the two separate equations. X plus 8 is equal to 0, and x minus 5 is equal to 0. When we solve, we see that x is equal to negative 8, or x is equal to 5. And if we were to substitute those values back into our equation, we should end up with 0. So if x is equal to negative 8, as we substitute it in, we're going to end up with 0 times negative 13, which is 0. Likewise, if x is 5 and we substitute it into our equation, we're going to end up with 13 times 0, and that's equal to 0. So we found the two possible values that x could be using this zero product property. Hey, that rhymed. We found the two values of x that it could be by using the zero product property. Hey, all right, cool. Look at that. And Poet didn't even know it. All right, so with this in mind, please work on problems 1 through 6 on the guided notes and turn them onto the backside when you're ready to move on. So sometimes you need to factor before using the zero product property. So let's solve x squared plus 4x minus 5 is equal to 0 by factoring. So to do this, we're going to factor by any method that you do. We're going to find that those two binomials after we're done factoring are x plus 5 and x minus 1, and those are equal to 0. So we're going to break it apart into two equations. X plus 5 is equal to 0, or x minus 1 is equal to 0. As we solve for x separately, we're going to find that x is equal to negative 5, or that x is equal to 1. Now let's just double check and make sure that when we substitute those values in, we get a true statement. Come on. Oh, it isn't working for me. So if we have x is equal to negative 5, as we substitute it back into our original equation, we're going to end up with 0 is equal to 0. We also, if we substitute it into the binomials that represent the original equation, we would end up with 0 times negative 6, which is still 0. We also found that x could be 1. So if we substitute 1 in for x into our original equation, we're going to end up with the true statement. If we substitute in 1 into the binomials that represent the original equation, we're going to end up with 6 times 0, which is still 0. And let's work with this problem here. we're going to solve 3x squared minus 12x plus 12 was equal to 0 by factoring. So one of the things that we notice right off the bat is we have a greatest common factor. That greatest common factor is 3, so we can factor out 3. As we factor x squared minus 4x plus 4 is equal to 0, we're going to see a couple of things. This time we're going to see 3 things. We're going to have the equations that 3 is equal to 0, which we know that can't be true. Or we're going to end up with x minus 2 is equal to 0, because this happens to be a perfect square trinomial, so we just end up with x minus 2 is equal to 0. If you were to write it again, it would be x minus 2 equals 0 or x minus 2 equals 0, so you don't need to do double the work, it's the exact same binomial. We're going to find that the only possible value of x is going to be equal to 2. And we can't have 3 equaling 0 because $3 is not the same as having $0. Having 3 cookies is not the same as having 0 cookies. So if we check our work and we substitute in x as 2 into our original equation, we do end up with a true statement of 0 equaling 0. If we were to substitute in the x value of 2 into the binomials that we found that represent the original, we end up with 3 times 0 times 0, which is 0. Now, before we move on to the rest of the problems of your guided notes, I just want to talk to you real quick about another situation. Let's say we have x squared plus 3x minus 1 is equal to negative 3. Let's say we have x squared plus 3x plus 1 is equal to negative 3. Now, we can't use the zero product property here because it's not equal to 0. So we have to have our quadratic equal to 0. It's an absolute must. We have to have our quadratic equal to 0. So let's make sure we jot that down. I'll jot down with you. We have to have our quadratic equal to 0. We have to. So in order for us to do that, we have x squared plus 3x minus 1 is equal to negative 3. We're going to have to add 3 on both sides. Notice where we're lining up our terms that we're adding. We have x squared plus 3x now plus 2 is equal to 0. Now is when we're going to be able to factor, and we'll find we get x plus 2 times x plus 1 is equal to 0, which is why we need to have our quadratic equal to 0 before we can factor, because now we can use the zero product property and find that x is equal to negative 2 or negative 1. So please make sure you have your quadratic equal to 0. Before you're able to factor, it has to be equal to 0. So you might have to do a little bit of manipulation to get it there, but please, please, please be aware that our quadratic has to be equal to 0. Now, with that in mind, please work on problems 7 through 15 on the guided notes. You're doing super duper well. Keep up the great work. Let me know if you have any questions, and I'll talk to you soon.